Let's decode this equation. We have two logarithms here of the same base under the process of addition. We have the logarithm of x to the base 10 plus logarithm of the quantity x plus 15 to the base 10 is equal to 2. We are going to solve for x that will satisfy the given equations. But before we do that, we need to really remind ourselves with the properties and important processes involving logarithms in order for us to solve the unknown. In this case, we have two logarithms of the same base that is added. We have an important property or a theorem in logarithms which tells us that if we have, let's say, the logarithm of a to the base b plus another logarithm, let's say logarithm of c to the same base b. Again, this is very important to be noted. They must have the same base, which is in connection to our given. We have the same base 10. We can rewrite this into one logarithm to the same base b, and you simply multiply the coefficients a and c. This is what happens when we try to add logarithm of the same base. Again, you just can combine them into one, and then, but we will not be adding a and c, okay? We will be multiplying them. So this is one of the most important properties when we deal with an equation like this. In short, if I'm going to rewrite it here, the logarithm of x to the base 10 plus another logarithm of the quantity x plus 15 to the same base 10 equal to 2. We have the same bases here, so we can write them into one logarithm. The logarithm of the product x and x plus 15 to the same base 10, and this is still equal to 2. Again, same base. It will not work if the bases are not the same. Now we can of course proceed with multiplying x to x plus 15 to get a representative expression, but let's move forward in the transformation of any logarithm a to the base b, and let's say this is equal to y, because we don't have we need to use another variable because x is already here. If we have a logarithm which is equal to any expression, you can simply write this in this form. Copy the base b. The equivalent here will become the exponent of base b, and your value for that is equal to the coefficient here, a. So this is the transformation from the logarithmic equation to exponential equation. But in this case, since our equality here is a constant, we will not have any exponential equation, but an equation with the same process. So the base is 10. You will have 10. We have squared. That's the equivalent of the entire logarithm here. Is equal to this expression. You have x times x plus 15. Since 10 squared is an exact value of 100, so we will have here a linear equation. Let me use the symmetric property, and you will have x times x plus 15 equal to 10 squared, which is 100. And this is x squared plus 15 x, then subtract both sides by 100 minus 100 equal to 0. Okay, we already subtracted both sides by 100 here. So we have a quadratic trinomial. Okay, we have here the quadratic trinomial, and to solve for x, because that's what we're solving for, we need to factor this using AC way. Okay, so AC is, we have 1 here, 1 times your c, which is negative 100. This is on factoring, so you also need to review your factoring, which give us a result of negative 100. Now there are plenty of factors for negative 100. You have 1 times negative 100, negative 1 times 100. You would also use 4, the negative 25, and the other way around. 50 and 2, negative 2, and the other way around. 10 and negative 10 the other way around. But we're going to look for the factor of negative 100 that when added will result to 15. We can use actually here 10 and 20 and negative 5. 20 times negative 5 is negative 100. But if you're going to add them up, you will have positive 15. So these are the coefficients for your AC method. And you can now factor this using that. You will have two binomial expressions, which will be equal to 0. Take the square root of x squared, x, and you place here these coefficients. You have x plus 20, and you have here x minus 5. And according to property of zero factor property or zero product property, this will only be equal to 0 if one or both of them is equal to 0. So equate both of them to 0. X minus 5 is equal to 0 as well. So we have two possible values. X can be negative 20 and x can be equal to 5. So we have two possible values for x that could satisfy the equation. But shall we accept both, or do we only select which is possible? We can trim down our possible answers here by considering that when we substitute the values of x here, this the value for the x and x plus 15 should not be negative, because we cannot have a logarithm of a negative number or a negative integer. When we substitute 5, our first expression is logarithm of 5 to the base 10. It's positive. And on the other side, logarithm of 5 plus 15 is 20 to the base 10. It's possible. But when you use negative 20, your first expression, logarithm of negative 20 to the base 10, is already undefined. And if you're going to proceed further for the next, negative 20 plus 15 is negative 5. So again, it's not possible. So this is not possible. So we say here, not possible. So the value of x that could satisfy the given logarithmic equation is only x equal to 5. We're able to solve this by understanding this property that will be converted to this. We also apply this transformation from here to here, and we have a quadratic trinomial, so we factor it out using AC method, and then finally you have your zero factor property, which give us two results. But of course, we need to decide which is the correct answer, or shall we accept both, or only one, or even none of them. That's mission accomplished.